Alright, so first we want to set up our layout. So let's go to our UMG folder here, and I'm going to make a new folder inside of this just because we'll have a lot of widgets for our inventory specifically, and we'll call this inventory. And we can open it up, and we have to first make a widget, so user interface, widget blueprint, for one singular inventory slot. So W inventory slot. So we can open that up. Dock it here. Our inventory slot, we don't want to worry about our screen size. So let's change this fill screen to desired on screen. The only difference, I think I mentioned it before, but the only difference between desired and desired on screen is desired on screen shows you the actual bounds of our layout, so you kind of get a sense of how big and small you are making your widget. So that's just why I prefer it. So we can delete the canvas panel, and let's add a size box. The size of this will be the size of one inventory slot. So imagine them in a 4x2 layout, or however many slots you want to have. For starting out, we're just going to have 4 slots horizontally and 2 vertically, so 8 slots. And we're doing this just to kind of see how much space we want it to take up on our screen. And I am going to be going with 120 by 120. So check width and height override, and just make the box 120 by 120. And you have 4x2 of these. I think that'll take up a good amount of space. So let's add a button to our size box. And after that, we need to put an image on top of it. But instead of just adding an image, we're going to add an overlay first, which allows palettes to be stacked on top of each other. And we'll come back to why we're using the overlay later. And we'll just put the image in the overlay. Let's just make the image fill the entire thing, or do that with the overlay, but we can leave the image to fill here as well. And take out the padding, so it just fills the entire thing for now. And then in the button, let's rename it to inventory slot, or let's just do slot button. And we want to make sure it is a variable. And then same with the image, we'll just call this slot image, and also a variable. In the button, we want to search for padding in here, and we can just take this normal and pressed padding to 0 for all of them, just so it doesn't have any padding when we click on it. The default padding is to give the illusion of the button going inwards when we click on it, but for the style of our own button, I don't want that. Next, we want to search for focusable, and we want to toggle is focusable to be off. This is so in the future when we have a complete array of inventory slots. When we press our tab button, which will be used to open and close the inventory, it will know to close the inventory menu rather than register the tab button as trying to select the next button as the currently selected button. So we can close that as well. So let's go into the graph, and we need a variable, and we're going to call this index, and it'll be of type integer. We need a index variable, so we know what index each slot is in the full inventory, because it'll be indexes 0 through 7 for our 8 slots. So each one needs a different number in our index. Let's make it editable, and we also want it to be exposed on spawn, so we can check that as well. So that looks good for now. Let's create a new widget. So right click user interface widget blueprint, and we'll call this W inventory grid, and this will be our grid for our slots. And we can open it up. And same thing, we want to change this from fill screen to desired on screen, because we don't have to worry about the entire screen layout. And we can remove our canvas panel. Just delete that. Instead, we want to replace it with a uniform grid panel. So this creates a grid for us. And you can probably guess that this grid will contain the amount of slots we want to have. So let's rename it inventory grid panel, and we want it to be a variable so that we can access it from inside our blueprints. So let's compile and save that, and let's go to our graph, and we have this event pre-construct right here, similar to the construction script in other blueprints, and we want to add a for loop. And this is not a for each loop, sorry, just a regular for loop, and this is where we're going to generate our slots. I'm just going to delete these two right quick. But we don't want to control how many slots we have in this blueprint. We want that stored in our player controller. This way, if we ever want to add or remove slots in game, it will remember how many slots we have as we go from level to level. So let's open up our player controller by going into our game blueprints and level 1. Oh, not level 1, it's right here, HG player controller. And we can create a variable, and we'll call it inventory slots. There we go. Took me a couple tries. And this will be an integer as well. We can compile and save that. I'm going to make the default 8, as we were talking about earlier. We'll compile it again. And we can go back to our grid. So now we have to cast to it. So let's get our player controller. And we can cast to our HG player controller. And we can right click and convert to pure cast, because we don't need to run it through the execution nodes. As the HG player controller, we can get our new variable, inventory slots. And let's subtract 1 from this and plug it into our last index. So -1, or integer minus integer. If you just type in the minus key, it'll come up. And we want to subtract 1 and plug it into our last index. We subtract 1 because the loop starts at 0. So 0 through 7 would be 8 slots. If we left it at 8, this would be 0 through 8, and it would give us 9 different executions to the loop body instead of 8. So that's why we have to subtract 1 from our... So in the loop body, we want to create a widget. And the widget we want to create is our inventory slot. And we now have this input called index. And the reason this is here, right in our create widget, is because in our slot, we made our index variable exposed on spawn. So it comes up right when we spawn in our widget. So we can just plug in the index right into the index. Now all 8 widgets we've created has a different number assigned to them in their index variable, 0 through 7. This will be very helpful when we need to add and remove items. We also want to promote the created widget to a variable. So let's do that now. Promote to variable. And we can call it slots array. That's because we're going to be changing it to an array. So let's actually just break these links, because it's going to complain. And click on this little icon here. Oh, not this one, sorry. Down here, click on this icon and change it to an array by clicking on that little grid. And it'll complain, just hit change variable type, and we won't have any errors. So we can actually just delete this and pull it out again and get the slots array this time. And we need to add to the slots array. So we'll add. So in our array here, every time the for loop is called, which will be 8 times, we add a reference to these slot widgets in a array. So there'll be 8 elements in our slots array after this for loop finishes. Now if we were to just end this here with our inventory slot widgets, and we were to press play with this on the screen, we still wouldn't see anything. No slots would be actually added to our view. And that's because we need to actually add the widgets to our uniform grid panel right here. So let's pull off our inventory grid panel, and we'll do add child to uniform grid. Plug it in right here. And for content, it'll be the return value of our created widget. Now we need to tell it which row and which column it'll be set in. We need to do some math for it to figure out how to add each one into the next section. But let's come back to that. First, let's go into our UMG folder and open up our main HUD. And let's just add our inventory grid to our main HUD. So if we go here to user created, it'll show us the widgets we've created. And here we have inventory grid. And of course, at the moment, it's completely empty. And that's because we actually add the slots in our graph. So it won't happen until we press play into our game. So let's, here on our inventory grid, let's check size to content. So it'll resize based off what's added to it. And we can just leave it on the screen because we'll be removing it in a minute. We don't have to worry about positioning it. So let's hit play. And I can see that white box. That white box is the inventory slot widget. Now it is actually adding 8 of them, like I said, but they've all been added to row 0 and column 0. So they're all stacked on top of each other. So we need to do the math to actually spread them out. So let's go back into the grid. And if we actually take this index here and we plug it into column, compile and save, and we press play, we now have this really long, wide box. Now this isn't actually a really long, wide box. This is all 8 inventory slots set up side by side right next to each other. There's no padding in between each slot, so they're all right next to each other, and it creates the illusion of one long box. And that's because the index is adding a new column for every single one. But this is also not how we want it. I'm just demonstrating that all 8 actually do spawn in. So we want our slots to start on a new row after the 4th one, or at least I do. You can choose whatever number you want, but I want it to be 4 slots and then go to the next row. So let's go back into our inventory grid, and we're going to create a variable, and we're going to call this slots per row. And this will be of type integer, and we don't want it to be an array, so we click this and change it back to a single variable. Now we're putting this variable inside the inventory grid because I don't plan on ever changing this in-game. I'm fine with it being totally static, so I don't have to worry about it being in the player controller. If you want, you could also put it in the player controller if you want it to update mid-game. I'm going to make the default 4, because that's how many I want. So for row here, we want to get our slots per row. Let's pull it out, we'll press get. And we have to get a divide node, but we don't want to get a divide integer by integer. We actually want it float by float. So let's plug this one into the B. It'll convert it automatically. And for A, it'll be our index. Out of the output, we want to get a truncate and plug that into our row. A truncate will always round a number towards 0. In other words, a positive number will always round down, and a negative number would always round up. For example, once we're on our 3rd inventory slot, which has an index of 2, we divide 2 by 4, and we get 0.5. This rounds down to 0 through our truncate, letting us know we are still on row 0. Once we reach our 5th slot, that'll have an index of 4 because we subtract 1 to get our index. We want to go to the 2nd row. So 4 divided by 4 equals 1, and truncating that will just give us an output of 1. For our 7th slot, it's pretty self-explanatory now. Index of 6 divided by 4, we get 1.5. That truncates down to 1, and we still are on row 1. So we can freely change this slots per row to how many slots per row we want, and that'll give us, and that'll accurately decide what row our slot should be in. Now we need to set the columns correctly, because right now it'll always just keep adding 1 for columns. So we can break that. We need a division node, division, and grab this one, division, whole and remainder. And this gives the option to input a dividend and a divisor. This will return how many times the divisor goes into the dividend. The dividend will be our index, so we'll plug that in. Actually, let's grab it from the conversion to a float. And the divisor will be our slots per row, so we can plug that in like that as well. In other words, we're seeing how many times the number 4 fits into our index. Let's take the 7th slot for an example. It has an index of 6, because the index is always one less than the slot number. 4 goes into 6 one time and gives us a remainder of 2. This means it goes into column 2. I don't want to overcomplicate things, but column 2 is actually the 3rd column because the columns also start at 0, as we can see. So let's truncate the remainder, because we need to convert it back to an integer. This isn't actually rounding anything because we're only working with whole numbers. And we'll plug the return value into the column node. So let's compile and save, and let's press play. So as you can see, we have this box. We have the first 4 in separate columns, and then it goes down to the next row, and we start off again at column 0, and it continues in that sense. So the way this is set up, we can go into our player controller and we can set the slots to whatever we want. So if we did like 11, should be 3 rows, and the 3rd row shouldn't be quite full. Yep. So it goes down to the 3rd row and it adds 3 more. And then you can also go into the inventory grid and change the slots per row. So instead of 4, say I wanted 5, and press play. And it now adds 5 at the top, and the next 5 are 6 through 10, and then that last one of the 3rd row is number 11. I'm just going to change this back to 4, and the inventory slots back to 8. Press compile and save. Last thing I want to do is add some space in between each slot so we can see them a little more clearly. Probably should have done that before the demonstration, but I'm pretty sure you got the idea. So let's go into our uniform grid panel, and in slot padding we can just give that a value of 10, so it adds 10 in all directions. So let's hit play, and now you can see we have our padding in between our slots.